Good afternoon and welcome to Metro Home Theater Tech Tips. I'm Brent.
I'm Adam.
And we got another great show in store for you. So tell me a little bit about today's sponsor and what we're doing.
Well, first and foremost, of course, like you said, our today's sponsor is the SFP PLC, and then it comes in different lengths as well. This is a pre-terminated duplex fiber. It's riser rated. You can go anywhere from 50 feet to 125 foot options. And so definitely reach out to your reps to find out the availability for you out in the field. The nice thing is, of course, it's OM3, it's riser rated, and it's already pre-terminated, and it's duplex. So you're actually getting 2 runs of fiber with 1 pre-terminated cable.
So even if you only need 1 piece,
yep,
you got a spare.
You got a spare.
And spare's good.
Yeah, which
Except
is actually
when it's here.
Part of, well, that's, yeah. Which, by the way, I've lost weight. Right?
Congratulations.
Yeah, I feel pretty good about myself. So,
which, by the way, I haven't.
Yeah, I was going to say, you picked it up for me, right?
Yes,
you found it for me.
I was down with COVID. Now I'm here. I tell you what, I'm gonna stand like this the rest of the show.
There you go. Everybody, thank you again for checking in with us on today's episode. Like I said, we will be talking about fiber today. Today's episode is, like I said, brought to you by the SFP LC050. Is a 50-foot one, but it can go all the way up to 125-foot.
Is that the minimum length?
That is the minimum length for that, yes. So, but today we are going to be talking about fiber, because fiber, it's what's for dinner.
I thought fiber was for breakfast. Okay,
yeah,
before we get into that,
that'll work.
Before we get into that, first off, we'd like to thank everybody who subscribed to our channel.
Yep.
Because the numbers are growing. Thank you very much.
Yes, thank you very, very much for everybody who subscribes.
If you have not already subscribed, please do so.
Yep.
Click the bell so you know when we got something new. And there's a lot of new stuff coming out with the Did You Knows, the box openings, and I think we're recording a couple more this afternoon.
Yes, we are.
So there's a lot going on. Don't forget to check us out on Facebook, Instagram, and Twitter.
Yep.
More importantly, call us if you have a question.
Yep. You can give us a call at 386-492-8584 if you have any questions about any of the product that we have, or if you're running into a problem out in the field, of course, that we are tech support. That's what we're here for. Or, of course, if you're designing a system or coming up with a plan, definitely give us a call so we can help out with that as well. So
knowing all of that, saying all that, let's jump right into this week.
Yep. Okay, so we're talking about fiber today. And we're going to go over a couple things. The first thing we're going to do is going to go back over again, what is fiber and how does it work? Because at that point, some people don't know. We're going to assume that some people who are watching this may be the first time that they're watching it. So we want to figure that out. So what is fiber and how does it work, Brent?
Isn't it like fishing line where I just cast it out there, catch something, and reel it in?
So if you're using a toss-link cable, pretty much. Because a toss-link cable is essentially just a plastic clear inside to it. In fact, I think I have some over here somewhere. And with that...
As he steps out of camera.
I do, yeah. So with the
which is very low bandwidth.
Extremely low bandwidth. Now, actually, what's interesting, I was doing some research. Today's not going to be as data intensive as the last couple of episodes. So
I don't have a whole sheet of questions to ask.
Exactly. So, but as I was doing some research on fiber, I found that a university somewhere was able to take a toss-link cable, which is, just I forget exactly the type of interior.
Well, now there are some toss-links that are glass fiber.
Yes.
You pay for that.
Yes, you do.
Multi-mode.
For instance, this one here is not. This is a plastic interior. The plastic's the wrong term for it, but it's something. It's
a nylon synthetic material.
Exactly. Now, what they were able to do is they were able to get 10 gigs down one of these.
How much power were they driving at the transmit side?
A lot.
Okay, because you got to push it hard to get through that fiber.
Yeah.
The advantage that glass fiber offers.
Yep. Fiber.
Wow. Yeah. You can't say that 3 times fast.
Yep.
Is the clarity and the lack of loss versus a synthetic material.
Right. Now, in many cases, all you're doing with this is, at most, you're going to be doing some surround sound, maybe a 5.1.
7.1 is it?
Yeah, 7.1 is the maximum for it. In actual use cases, you can go higher than that. It can do as that one university was able to prove, but you're going to be doing HDMI with the other connections. Now, so what is fiber? Fiber is a medium that we use to get data from one end to another using light. And so that's basically what fiber is. All that inside there is you have glass fibers, or a single glass fiber going from one end all the way down to the other end. And on the transmit side, all that happens is that a light that we can't see as humans, it just blinks on and off essentially. There's more involved into it than that. but essentially all that happens is it blinks on one end and the other side reads that blinking as something else. Essentially, it's the same as you taking your infrared remote, pointing it at the TV and hitting a button. Your infrared remote is going to blink on and off and send a certain type of signal over to the TV to tell the TV what to do, and TV is going to receive that and know that code means to do something.
Now here's the important part. When you're looking at fiber, we tend to think of things as, okay, you shine the light in one end, it shoots straight down the cable and it comes out the other end. Does not really work like that because it does work on reflective properties.
Right.
So when you have a piece of fiber, and that's the thing with fiber, with the glass or nylon, it's not just the fiber, it's the cladding around the fiber.
Right.
Because you have to enter the data at a specific angle, in which I'm going to be wrong in my drawing, but...
You want to see the top down?
Yes, I do.
Yep.
Data enters, and then it's bounced all the way down at a specific angle. Now you can have multiple data ports feeding down the same fiber simply by changing the angle of incidence.
So what's really interesting about this as well is that when you're changing that angle that you're sending the data down, that also means that you can actually send data both directions.
Yes, you can, because it can be multiplexed.
Exactly. So we're just changing which frequency or which angle that light is then being sent down the cable. So you can have a cable that does bi-direction with that. Now, there are some cases where you would use a duplex cable, which duplex means two, of course. Simplex means one. A duplex cable where you would have an SFP module, which we'll get to that as well, because that's what we use on our fiber extenders, our HDMI over fiber extenders. There are some SFP modules that have both a TX and an RX side, so two separate connections.
And typically that's less expensive than trying to put it all together.
Right. It also allows for a higher bandwidth because the physical electronics, that's really the only limitation that we have right now, is the physical electronics themselves doing that transmission.
Cost goes up as you add more reflected beams inside of a fiber. The cost of that driver and receiver goes up dramatically.
Yes.
So if you have just one, it's X. If you have two, 2X, 3, 3X, etc. So the more expensive the system, typically the more data you can pass.
Right.
Now that's not the fiber proper.
No.
That's the electronics at each end of the system.
Exactly. So that's where your SFP modules come into play. As always, everybody, thank you for checking in the video. If you have any questions about what we're talking about today, feel free to leave it down in the chat. If you were catching this after the fact, you can put your questions and comments down in the comment section below. We do monitor that, so please go ahead and do that. We try to respond as quickly as we get them. Even if it has nothing to do with what we're talking about today, we're happy to hear from you as to what kind of questions you have, what you have going on out there, so that we can go ahead and discuss that as well.
And tomorrow morning we will pull up YouTube to look at our diagnostics to see how excited we were today.
Yeah, exactly. So
please subscribe.
Yes, thank you. Okay, so that's what fiber is. It's just basically a glass fiber, literally just a glass
with a
fiber
laser
inside
flashlight.
there. With a laser light. Actually, this is kind of cool here. If I do this, watch, ready? It's basically just a laser light, right?
Ooh, look at you.
That's kind of fun. So it's just a laser essentially that's at a frequency that our human eyes can't see, and it's just sending it from one end all the way down to the other. That's pretty much it. There's not a whole lot else to that. Now, how it works, of course, is a little bit more involved with it. You can get really far down the rabbit hole as to exactly how it works, and there's many ways to do it. That's not within the
glass. That's within the electronics.
That's within electronics. Now, to an extent, because the glass does have an effect. So you'll notice that I said earlier that the pre-terminated fiber is an OM3 fiber. So there's a difference between OM1, 2, 3, 4, 5, and I think now they're up to 6 and 7, I believe. We use OM3 in all of our products that we have. So our HDMI over fiber extender uses an OM3 fiber. Now the neat thing about that is that it's the SFP module that determines what type of fiber you need to use. So if you were to change this out with an OM2 or an OM1 SFP module, technically you could use that with this HDMI extender and it would work perfectly fine.
As long as you're within the bandwidth of those fibers.
Exactly. So now, when you are also looking at, there's OM3, so which is a multi-mode now, and then you have a single mode. Now, you would think that multi-mode versus single mode means, well, multi-mode means we've got different angles and everything, and single mode means we're shooting straight through. Kind of. There's a little bit more involved with that, and there's a lot more research on my end that needs to be done so that I fully understand it before I can give that information to you and make sure it's true information. However, it's less about different angles versus a straight shot and more about just the type of data and how they send the data. It's not and almost like a packet, the type of communication that it is. So you may have something that's a toslink information versus something that's an HDMI information. And so it's still data, it's still going down down the cable.
But data's data. It either works or it doesn't.
Yeah. You're funny. Don't call any names. So be careful. So here's the deal.
That was just nasty.
Well, I had to stop you. I had to stop you before you did something.
You did, but that was.
So that's how fiber works, and that's what fiber is. So our next question that we have, of course, we're flying through these pretty quickly. We only have a couple of them, but the next ones are a little bit more involved. So the next question comes down to, what do you need for fiber? Now, this one's a little bit
cereal?
Bigger. You get the Raisin brand.
2000?
There you go. The giant Raisin, Raisin brand.
32 bowls.
Brand. Yep, exactly. Yeah. You like that joke too much. It's too much. It's too much.
Oh man.
So
fiber's important.
With the what do you need for fiber? And we're going to go into detail about not only what kind of tools you need, but what do you need to do in order to run fiber correctly. So let's actually start there, because we may not have. We run the fiber before we terminate it, or we have something that's pre-terminated. So let's talk about running fiber. What do you need to do to run fiber?
Be careful.
Be careful. So the first thing that you need to do, of course, is make sure that you know the path that you're going is nice and clear. You don't have any sharp turns. We want to make sure that the fiber is kept to at least 6 inches in diameter for any kind of bend radius, which, to give you an idea, that right there is about 6 inches in bend radius. So what that means, and this is something that as a new installer, I had to kind of understand, well, what does that mean, 6 inches in bend radius? What does that totally mean? And so just in case somebody who's watching doesn't know what that means, it essentially means that if at any point that fiber is going around a bend at any point, if you were to continue that bend all the way into a circle from one side to the other would be 6 inches.
By the way, a good way to handle this up in an attic, honestly, is to use vac pipe parts.
Yes. Yep.
So if you're going a long distance and you want to protect them, I'm not saying do the whole thing in vac pipe.
No.
But where you've got the bends and the returns going into the walls,
yep.
The vac pipe, the soft sweep in a vac pipe, not the hard sweep, but the soft sweep, is the best way to handle that. It's inexpensive product.
Yep.
There's mounting accessories already available to do that.
All over the place.
And it's a great guide, and it protects this from you.
Yep.
And I can promise you that we take a look at all the fiber products that come back.
Yep.
Anything that's defective, because we want to make sure we're not getting bad electronics.
Yep, exactly.
And to date,
almost every single one that's come back has been because of
installation error.
Yeah, installation error. So when you have that bend radius, the other thing you want to make sure is that it's not, other reason you don't want it to be super sharp or super tight is that as you're pulling it, it's going to snag and it's going to create resistance on that. So if you give it a nice swooping sweep, however you want to say that, as long as you're going around that 6 inch radius, it's going to help you to also pull it through. It's going to make things a little bit easier to actually get around those corners. So technically fiber, you're looking at about 30 foot-pounds of force in order to pull that fiber. Any more than that and you're going to be causing damage. My recommendation, if at possible, be under 30 foot-pounds of force, 25 to 20 foot-pounds of force.
Which means you want a feeder as well as a puller.
Exactly. One easy way to tell, okay, how much weight am I putting on this fiber? Go grab a dumbbell or something like that and lift that dumbbell. That's going to be about 25-pound dumbbell. Yep.
No, that's more than 25.
No, yep. So oh man, you messed up my collar. Don't do that. So go grab that dumbbell, pick it up. If about 25 foot-pounds, just get the idea about how much that's going to weigh at that point, and that's going to be about how much force you need to actually pull on that cable.
Or just put it in conduit.
Make your life easy.
Smurf tube is really the way to go.
Yep. So
because you're not going to get tighter than about a 12-inch bend radius on that.
Now we had early in our when we first released fiber, one of the first phone calls that we got was, and this actually goes into the pulling force on it, because one of the first phone calls that we got was about the fact that this gentleman installed the conduit. He went 370 feet or something like that, which is fine. It's well within the distance.
Yeah, but that's a lot of pull-through conduit.
So, yes, it is. But what he was doing is he was going from a building to a gate, and because at that point he needed to get internet service out of the gate. So what happened, of course, is that he went to go pull it, and he was pulling it as though it was just regular speaker wire or coax cable or whatever, and yep, just pulled it, and I got caught on something, and he says he pulled it even harder. And by the time that it made it to the other end, what was really interesting is how it broke. Because it wasn't like it broke at one point and then it was ruined from that point. It was actually, as he was pulling it inside, what we found out later on was that the conduit had actually separated underground because it wasn't glued entirely. Separated underground and went off, kilter from each other. So like one conduit piece was here, one conduit piece was here. So he was actually going like that. He had a string, so he tied off to the string, but the problem was that it went kind of out one side really sharp and then into the other side again really sharp. So what would happen was about every 4 inches or so, there was a break in the fiber, because about every 4 inches is about where that bend radius finally cracked, and then it bend radius again and cracked. And so at that point, about every 4 inches or so, he had light shining through that. Now, when I say light, it wasn't specifically, normally if you were to hook up a fiber connection, you wouldn't see that light. But in the termination kit, you actually have what's called the visual fault locator. So the visual fault locator is a pretty simple tool. All it really is a laser light. So on the inside of it here, somebody has stolen my batteries.
Like this one?
Yeah, like that one. Nope, bottom. That one right there. There you go. Are you going to be able to hit it? You think you can? Basically, it's just a laser light with fittings on the end of it here. In fact, I'm going to switch over to our top-down, Brent, so that they can see what this looks like. Again, if anybody has any questions about anything like this, feel free to put it in the comment section or the chat below. So it does have, of course, a connection inside here. Now, this, of course, is meant for an SC connector, but you do have an adapter in that termination kit to go from the SC connection over to an LC connector. So that's all it really is to go between, or for testing that cable. So when this turns on, of course, it's just a red laser light, but the really cool thing about it is that those breaking points shone through the jacket, and you could actually tell where those breaks were at. That's why it's really important to have one of these. When
you're looking at fiber, traditionally the breaks are not big breaks. It's micro fractures, little fissures, small little breaks in it that look more like spider breaks in a windshield.
Yeah.
Not a big break, just little tiny ones.
Yeah. Now, in that case, you probably wouldn't be able to tell you wouldn't be able to see it so much because it is so incredibly small. We're talking 125.
But you'll get data loss, and you'll see bandwidth drop from 4K to 1080 or 720 or 480.
Right. Now, that's especially true in our HDMI AOCs, which have 4 OM3 fibers inside, and if one of them begins to go bad, we begin to lose bandwidth capabilities. So the neat thing is that, yes, when it breaks, what's happening is those microfractures in there are actually refracting or reflecting the light inside that towards the edge of the fiber, and that's why the red light would actually show through the side of the fiber casing for that. So it's kind of an interesting thing to see. I have some pictures on it. Maybe I'll put those up later on, but those are definitely some interesting things to see for that as well. But now that we've talked about how to run fiber, or rather how not to run fiber,
gingerly,
yep. It's still, listen, it's glass. It's definitely more durable than if you had just straight fiber by itself, because you do have the outer jacket, the outer sleeve, the inner insulation.
Plus
then you have
cladding.
the cladding on the inside, and then of course finally the fiber is designed to be bent because it's like a glass
not
alloy
for
of
nothing.
some kind.
You need to treat Cat 5 and Cat 6 with the same level of concern.
Yeah, we did an episode a while back, almost a year ago now, where we talked about how you should respect the wire.
Yes, because if you yank on even copper cables, whether it's a Cat 5 or an HDMI cable, changing the geometry of that wire is effectively the same thing as creating the microfractures within the fiber.
Yeah, yeah. So Todd, really good point, and good on them for that piece. He's talking about a competitor. And their pull strength on that. So I'd be really curious to see.
Do they have additional jacketing?
They must have some kind of additional jacketing with it. That's something that I'd have to look at and see. But yeah, it's good on them to have some kind of pull strength with that. We're saying with our piece here, we recommend less pull strength rather than at a certain point, if you start pulling too hard, you're going to damage something at some point.
It really is always best in pulling fiber to have a feeder.
Yep.
You know, two guys to make sure that nothing gets bound up. Communication's important because you don't want one guy to just start tugging on it and break stuff.
Yeah, exactly. So it's definitely worth it to take some extra time to don't put too much pull strength on it. Like we said, even for standard cabling or copper cabling, you really shouldn't be putting way too much pull
no, about
pull
30
pressure on it.
pounds still.
There should be plenty.
Because you're starting to deform the geometry of the cable and it affects bandwidth.
Yep, exactly. So now that we've talked about how to run the fiber, how to get it to where it's supposed to go, let's talk about actually how to terminate it. Now, I'm not going to go through the process of terminating the fiber here. We have other videos on our channel that you can go and take a look at.
Please do.
Please do, yeah, of course. But with our kit here, of course, the main thing is that you need some kind of kit to terminate that if you are not using pre-terminated fiber cables. So with our kit here, of course, I've got a couple extra samples here with it as well. But in here, one of the biggest things that you're going to need out of this kit is the fiber cleaver. Now, the fiber cleaver just simply is that. It cleaves the glass fiber inside. Every single type of fiber that's out there that's using a glass fiber needs to have some kind of cleaver like this. You can come back in, Brent. I'm not doing anything else.
Okay.
It needs to have some kind of cleaver because essentially what this is, you have to make sure that when you terminate the fiber, when you cut the fiber for use, when you're just running the fiber and you're using your Kevlar scissors to actually cut the fiber, it's not that big of a deal because it's just a bare end.
Right, you're just getting it there.
You're just getting it there. But when you are actually ready to terminate it, you really need to use a fiber cleaver because what you're trying to do is make sure that the end of that fiber is perfectly flat across the front.
Because of the angles.
Because of the angles. Because if the light, if you have it off by even just a few microns of a fraction of a degree, what's going to happen is that's going to change the direction that the light enters that connection or exits that connection. At that point, you're going to wind up with refracted light, and it's not going to get to where it needs to go, and you're going to have lower bandwidth because the system has to then reorient itself to be able to use that. So definitely make sure you have a fiber cleaver. Now,
by the way, you do need to take the same care when dealing with copper. One of the issues we see with HD-based extenders is when they use a tool to cut the cable, if it's not a sharp tool, you'll wind up with a slight angle or a tip on the end, which affects your distance, your length, and your connectivity.
Yeah.
So it's the exact same things we've been preaching to people for 15 years. On category cable, have to be done with fiber. The big difference is generally if you cut copper and something happens with one little copper pieces, it doesn't enter your skin and float around. Be very careful with the glass fiber.
So one other thing, Todd, on your question about that I would be curious about with Clearline, even with their fiber, I would probably recommend pulling it with less force than anywhere near what they're saying that it's capable of. One thing that we did as a test here with our fiber and with our HDMI over fiber extender is I did take our fiber and I pulled it way too hard. I also tied it into a knot and pulled it tight. And it continued to work perfectly fine. However, the thing is that that's only at 10 gigs. That's not getting a full 40 gigs across that connection. So I would be curious to see if they recommend doing that and still getting the highest amount of bandwidth across that. But again, check it out and see what it is. I'd love to hear back from you. Feel free to put that down in the comment section below and we'll talk about it later on. So with that, now like I said, one of the most important things is the fiber cleaver. Now with our fiber cleaver that we have, that's interesting that maybe you may not have on other fiber cleavers, is a waste bin. So on the fiber cleaver, what we have, of course, is we have the opening here. So we have our cleaving wheel, and then of course we have our waste bin. Now this is important. Brent, why is this important?
Because when you cut those little tiny slivers, they go places.
They go places.
And you want to know where they are because they can get into your skin, enter your bloodstream, and it's not pleasant.
No, it's not. So this is one of those things where when you are on the job site, make sure that you dispose of those fibers. Now,
just out of curiosity, why does fiberglass cloth itch when you get on it?
Why, Brent?
Because what it is little tiny slivers of glass that cut you, and you don't see the cuts.
There you go. They're super small at that point. So yeah, make sure that you clean up the fiber very well. Make sure that any kind of fiber cuttings that are left over, either make it into the waste bin on the fiber cleaver or make it into a waste bin of some other kind.
Preferably not a plastic bag waste bin.
Some competitors will do the thing where they'll say, oh, well, here, it's the bare fiber, and they'll start stabbing their hand with it and it doesn't do anything. Ours does the same thing, but I still don't recommend it for anybody's fiber.
Because at that point, it still has the jacket on it.
Nope. At that point, it does not have the jacket on. It's straight fiber. Technically, I did test it myself. I did it to myself. So I didn't.
Why did you not invite me to watch?
Well, see, here's the thing. I was going to invite you, and I was not going to tell you what I was going to do, and I was going to do it to you. But I thought, I still want to have a job.
You know, I'm old and fragile, right?
Yeah, and you know, I needed, you know, young skin that wasn't going to puncture for, you know, looking
resilience.
at it wrong. Yeah, exactly. So,
thanks.
Here's the deal. When it comes to any of this stuff, it's fiber. It's micro glass. We don't want to be poking it on anybody or anything on purpose, or let alone on accident.
Yeah.
So, with that, of course, the next thing that you'll need in your fiber kit, and of course we have the fiber kits available as well, contact your rep about the price on those, is the fiber strippers. Now with our fiber strippers, and Todd, I know you're going to be thinking it or possibly ask the question about it, our fiber strippers are 3-layered. So we get the outer jacket, we get the inner shielding, and then the last that we have is the cladding. Now there are competitors that do things where they'll say, well, you can just use your fingernail on the last little bit of cladding. Their design for their cladding is very interesting in how it works. However, we say, don't touch the glass. Just go ahead, use the third one on the stripper. Don't touch the glass. You can use that instead.
Yeah, you get oil on it and it will affect transmission. So
now you'll see in the other videos that I've done before, that third one also has me just going ahead and just cleaning off the last little bit of it. That's perfectly fine. When you go to cleave it, you don't want to touch the end of it after you've cleaved it, because that will put oils on the end of it, and again, we're going to refract and reflect the light, changing how it gets to the sensor or from the emitter. We want to make sure that we don't do that. So the last thing that you're going to, or the last couple things that you're going to need for the fiber when you're doing the terminations is, of course, the terminations themselves. So, of course, you've got your LC connectors, and you have, your LC connectors and your SC connectors. Now, the differences, of course, are it's just a connector. It's the difference between
application.
It's application. Some connectors use an LC connector. Some equipment uses an LC connector. Some equipment uses an SC connector.
It's the difference between 568A and 568B.
They're essentially the same thing. It's just the
slightly
shape
physically
of it.
different.
Yep, physically different. It's just whatever they want to use. On all of our equipment that we currently have, we use LC connectors, and that's what we see happening out in the wild, even for networking equipment. And actually, that does bring up a couple things that we're going to be talking about in the next part of the video. But now that you know how to run fiber, how not to run fiber, and also what you'll need for fiber in order to terminate it and to get it to that point, let's talk about what you need to make the connection to the devices. So, while I was talking about the SFP connector, no, that'll go back there.
You're not putting that in there?
Yeah, that should go in there.
That's what I thought.
Is that what you were pointing at before?
Yes.
Oh, okay. There you go. I put it in there wrong, but that's okay. So, what you'll need, of course, is how to get the connection from the device that you're connecting to the fiber. Now, the way to do that, of course, is with the SFP connector. Now, this is an SFP to go, or module to go from like a network switch or from our HDMI over fiber extenders. All it really is just a piece of equipment that will have this connection on one side, that is the copper connection, and on the inside of here, and very, very tiny, way down inside there, is what we call a VCSEL, right? VCSEL. So down in the VCSELs, what it is it's either an emitter VCSEL or a receiving VCSEL. And down, what it does is one side emits and one side receives, and all that this really is doing is just housing all of that in there and giving us the connection between the two. So this really is the limiting factor as to how much bandwidth we're going to be able to see down fiber, because all it comes down to right now is the electronic portion to it, because that's what's limiting us for the bandwidth. We are seeing, of course, right now, we are in the universities and colleges and stuff where they're actually testing a lot of this stuff. They're seeing bandwidths of extreme speeds. We're talking terabytes and petabytes, maybe not petabytes yet, but terabytes worth of data very, very quickly over something like this. But you won't see in their tests something of this size. You won't see an SFP module.
No, it's a large, power-hungry device.
It's a purpose-built thing for them to test it and everything else. So right now, what we are seeing, though, out in the wild is 40 gig.
Right,
so,
and again, remember, the limitation is this, not the fiber.
Right.
Now, your different OM 1, 2, 3, 4, 5, 6, whatever, will improve your capabilities. And the newer numbers are made to go, in some cases, to 100. under the assumption you're going to have
Yeah.
the proper electronics.
That's why it's important to have good terminations. It's also important that you are not running that cable incorrectly. Make sure you're giving it good, even
because the higher the
poles all the way across.
bandwidth, the less it takes to interrupt it.
Right.
Even on fiber.
Yeah. Now, and that's something else. As you're pulling it through the different areas, make sure you're pulling it with good, even pressure. We're not jerking on it. We're not grabbing it from up off the floor and starting it pretty hard. We're giving it good, even pressure up to that point so that you can get it across. So, now, the next thing that we have, Brent, of course, where's my little clicker? You stole my clicker.
I did steal your clicker.
I did steal my clicker.
Because it's got a cool light on it.
It does have a cool light on it. I like the little light on it. What's the next question? Next question. Fiber for network versus AV.
Okay, I'm going to defer this one to you.
Are you now?
Yes, because I use media devices, but I want to see what you know.
Okay, so not much, I'll be honest. When it comes to the networking side of things, the differences between network AV and network fiber versus AV fiber. So the differences between network fiber and AV fiber are pretty slim.
Yes, in fact, if you were to take that particular piece of fiber,
Yep.
which if you'll give an overhead,
switch it over? Yep.
is really a network piece of fiber.
Yeah.
It's for media links.
Yep.
Little boxes that look very much like this that have fiber on one side and an Ethernet on the other.
Yeah. All it really does is just convert it from the electrical Ethernet
mechanical
connection.
electrical impulses into flashy lights.
Yep, exactly.
It's all about the photons.
And then back over on the other side.
Yep.
So actually, going back to the gentleman that I was talking about before, what he was doing at that point was he would take a inside the house. He took his network switch, went out of the gigabit connection on the network switch into a media converter. Mm-hmm. The media converter then took that connection, converted it over to fiber. Now, if I remember correctly, that one was a single mode, it was a multi-mode over an OM3. But it was going down just one RX-TX connection, so it only needed the one fiber.
Because all it was supporting was one camera.
There wasn't a lot needed
intercom.
for it. Yeah, exactly. And even then, right now, the highest that anyone's really looking for is 10 gig, which is very easy to obtain.
That's still a lot of data to support a camera, an intercom, and a gate relay.
Right. Usually 10 gig at that point, you're talking about connecting campuses from one side to another or something like that. But in his scenario, he just took a standard 1 gig media converter, put Ethernet on one side, fiber out on the other side. He went over 370 feet or so down to the gate. Now, he already had power out of the gate, so he was okay there because, of course, we're transmitting power down the fiber connection. I think I said it in an earlier episode. They tested it. They can.
But you got to drive that.
But you're losing something like 90% of the efficiency on it, if not even more than that. So yeah, it's not worth it. We're not seeing anything like that anytime soon. So there won't be a power over fiber or POF anytime soon. But what he did, of course, is on the other end, he did another media converter, which took the fiber in and gave network out. And then from there, he just went into a network switch. Now, could he have gone into an SFP adapter into a network switch directly? Yes. But the switch that he had only needed 2 ports on it. And so he decided just to get a regular 2-port
and there's
media
plenty
converter.
of those out there.
Yep, there's plenty of them out there. Definitely do a quick search for media converter on Google, and you'll find it out there as well. So, what's the difference? So, what really does the difference come down to, and when should you use it? Application.
I mean, if you're doing, for example, AV over IP.
Yeah.
You could do that with a standard media conversion once you're into the IP state.
Yeah.
Our philosophy is less is more.
Yeah.
So if we can HDMI into a device and go straight to fiber,
yep,
it's less connections, less latencies, less loss, less. Less
encoding, less decoding, less conversions, all that kind of good stuff.
So, yes, you could do that.
Yeah.
But then you're having to take it from HDMI into IP,
yep,
then from IP copper into IP fiber.
Yep.
And then at the other end, whatever that conversion process needs to be. So there's at least one more piece of electronics in the chain, if not more than.
Right. So Brent, let's also talk about what happens when we go to do an installation at a house. When should we use fiber at the house? Where should we use it inside the house? And how important is it to put it in now?
Well, this is an interesting, because you and I had a deep discussion on this. Mm-hmm. We don't really need to do access points in fiber yet.
Right, because you still need power there, for one,
that's the thing.
and it's not really bandwidth.
Right, it's the bandwidth, we have plenty of bandwidth left with Cat 6A. What we really need is power to the WAPs.
Right.
So fiber's not really the answer there.
Right.
However, if you are maybe going to put a media server in the theater,
Yep.
and it's not where your internet location is or your primary location, it's worth having that backbone in fiber or to an office.
Yep.
You certainly want to lay fiber in for any potential video connectivity routes.
Yes.
I would also recommend it for audio connectivity routes because of IP.
Yep. So when the places that I like to put it in are from the demarcation point to the central CAN that's inside the house or the central location.
If you're putting it in a demarc, you need a large exterior box typically.
Typically, yes.
Because we're still, even though there's fiber in some areas, it's still mostly copper from the street to the demarc.
Yep, but it's good to put it there because in the future, they are pushing more and more fiber to those areas. So it's good to have it in those places as well. So some of the other things...
Gigabit internet's reality.
Yeah, it is, and even higher than that. We're seeing more fiber service to the house, and it's coming in more areas. It was actually interesting. If you look out and do some research on it, you'll actually find that there is fiber in the ground that's still dark to this day. Dark meaning, of course, that we're not using it. It's still dark to this day. That was put in the ground back in the 70s, if not even older than that.
I wired houses in the 90s with fiber that's still dark.
Yeah, exactly.
Celebration down by Disney.
Yeah. Yeah, so in those places, the thing is that those dark fiber will, could be turned on. They could be used because the thing is that technically it's still glass. It's still basically the same information.
Now, it's going to be an OM1 or an OM2.
It may not even be. No. It won't be an OM1. It'll be something else. I forget exactly what it's called, but it's still dark, and the point of the matter is that it's still usable, and so you use the same information when talking to your clients. Mr. and Mrs. New Home Buyer, we want to go ahead and get your house ready for the future and for today. And we say at this point, there's a couple places that we want to put fiber in because
Duplex.
You may not use it right now, and that's okay. It's relatively cheap. We might as well put it in there because at some point you're going to use it. So let's put it in there and have it to where in the future we don't have to break open the walls if we didn't put conduit in, which again, Brent, when should we use conduit?
Whenever possible.
So make sure that let's get that fiber in there now. But where should you put it? So my points that I go to, the demarcation point to the central CAN or the central rack location or wherever you have all, wherever you would have
distribution point.
Yeah, your distribution point. Wherever you would have the modem usually is where you want to put that. And then from that point, I would go into the main areas. I would go to the living room or den, whatever you want to call it, or great room or family room, whatever you want to say it. Very good question. We'll get to that here in 1 second. So I would also take it to an office location and to the master bedroom.
To any outbuildings.
To any extra
barn
buildings
or a garage.
Yep.
Because you're going to want that bandwidth if for no other reason video surveillance.
And a barn is a really good example for that. Let's take, for instance, if you are, my wife and I own horses, and it's important to monitor those horses in certain circumstances because, let's be perfectly honest, horses are trying to kill themselves. And so
you.
It's, and you, yes. And so it's good to monitor them and make sure that everything is perfectly fine because every once in a while you may just want to be like, hey, something made a noise out there, let's see what it is. So instead of walking outside and getting eaten by whatever it was, instead, you can turn on the cameras, and fiber's a great great use for that because you can go from your house out to the barn across a fiber connection, and it will work really, really well almost all the time.
Tie that into a media converter with your IP cameras, and life is good.
Yep, exactly. So there's also going to be people that will say, well, where else should I put it? Well, truthfully, wherever you can, wherever you're running copper connections, you should be running a fiber connection. The bandwidth requirements as we move into 8K, 10K, 100K, whatever it is that we're going up to, it's going to need more bandwidth. And the truth of the matter is that copper is going to run out of that bandwidth. We can push it, and in fact, in the next couple generations, we're going to see more bandwidth going down copper with different tricks and whatever else to make it work.
Different electronics.
But the truth of the matter is that eventually we're going to reach the end of that. Fiber really is going to be the next way to do it, the best way to do it.
We're not quite there yet, but we're reaching a point of parity.
Yeah.
For cost for performance.
Yep.
Up until now, copper's been substantially less expensive than fiber.
Right.
That's starting to change, and particularly with an AOC cable.
Yep.
You put an active optical HDMI cable in.
Yep. Let me see that.
If something happens to the HDMI portion, you've still got 4
Yep.
fiber cables in there that you can use.
So,
which we've already had people had the occasion to use because of damaged terminals or other things in the field.
Yep. So this is actually also really exciting, and it also has to do with Todd's next question. Todd, great question. I like this one because truthfully, maybe soon, maybe not for a while. We'll see, but we'll talk about that here in a second. But good news, we've got our new HDMI
8K.
AOC 8K 48 gigabit per second fiber cables available and in stock. I checked before we did our live stream today.
Buy early, buy now, because they may not be here tomorrow.
They're going to run out pretty quickly. In fact, we released these earlier with a super limited amount and ran out
much faster than anticipated.
Pretty darn quickly, if I remember correctly. So that was kind of a
thank you,
soft
Samsung televisions.
Actually, that's what happened with that. But they are available now. I don't know the links. I did not memorize that, but definitely check it out. Go on to metrohometheater.com. Look up the model of this is the EHV HDG2. So it's a really, really, really great cable. It's going to get you 48 gigs at the distances that you're going to need to run them. So now to talk about that, well, as Brent was saying, this is what's called an AOC. This is active optical cable.
Wow.
Right?
You remembered that.
I did, yeah. Active optical cable. And what that essentially means is that it's fiber. So there are copper connections inside of it for the 5-volt connection, the hot plug, the DDC or the EDID and HDCP connections, as well as a couple others for like CEC and ARC. But the rest of it, we have 4 strands of fiber, one for each of the TMDS lines. Now, which is very similar if you are familiar with our AOCs from, thank you, Vanna. If you're familiar with our AOCs from the install bays or even our VLOX for the generation before this, there are 4 strands of fiber inside of there. It is OM3 fiber, which is the same as our either bulk fiber or our pre-terminated fiber. So like Brent was saying, if you were to accidentally run this backwards because it is active, you need to make sure that the source is at the source side and the display is at the display side.
And it does happen.
And it does happen. I've done it. He's done it. Have you done it? He's done it. Lots of people have done it.
Just know that there is a rude gesture behind the box.
So it happens. And that's okay because you have options for getting the connection out there for that. Now, 48 gig options, not yet. They're on their way, but you have options. So at that point, some of the other things that we need to talk about or one of the questions that Todd had was actually really good. So Todd asked, when is HDMI going away and direct SFP connections on both ends?
I don't think it will. And it's purely from a security standpoint for intellectual property protection.
HDCP.
Yes.
So
because
now,
SFP modules are not required to have
the data could technically be encased inside of some kind of HDCP
yes, but there's
protection.
When you have an HDMI terminal and you have the HDMI electronics that come with that terminal,
right.
HDCP is mandatory inside of that.
Right.
That's not the case with SFP. So you could throw little tricks in to fake that out.
Yeah.
So is it possible? Sure it is.
Yeah.
Is it likely? I don't know, because the assumption is this is going to be 6 feet from whatever your source is.
Yep. As we move, and especially as we move into more all-in-one devices where the TV is your streaming device or whatever it is, we're going to see less of a need for an HDMI connection for video and audio and more of just an internet connection for bandwidth connections for the streaming services. So not yet. And you're right, your office switches are all strictly SFP. So now, do you have one of those really cool Cisco all SFP where it's got the SFP, each one of the ports on it is an SFP module? Or is it just where you have 2 SFP ports on the side of it? Kind of like this guy over here, which I was going to talk about, but apparently talked over it. This one here is a 48-port PoE from Luxel, and it actually has 2 SFP ports on it as well. Am I breaking stuff?
You are.
I am. Would you give me a top-down shot?
I am.
So at this point here, we have 2 SFP modules. And like I was saying before, with our HDMI extender, it's using the same type of connection. All it is just an SFP module that can also slide down in there. So all we're really doing is we're using the same type of information. We're just sending different types of packeted information from one end to the other. So we're not necessarily encoding for IP, we're just encoding for HDMI.
Right. It's just whatever the data is hitting it.
Yep, exactly. So those are definitely what you see out in the wild for different fiber connections out there. So this boy is chunky because of the PoE. It needs the extra power supply for it. So, but a great piece. Yeah. So that's basically what the differences are between fiber for AV and fiber for networking. Essentially, it's the same thing, but it's the type of data that's being transmitted across the fiber. So run fiber now because you may use it for networking in the future, or you may need to use it now for video.
AV. Yep.
So it's definitely something good to have with that. Now, some interesting news from the industry.
Okay.
Okay. Interesting industry news. Say that 10 times fast.
Would it be that Nest is getting out of the video, or the security side of video surveillance?
No, that's new. Where'd you hear that from?
I saw that on CE Pro. They've decided to cancel their alarm systems.
Oh, well, that's kind of interesting.
Yeah, it was not a happy moment for them.
That's a Google thing anyways. Google likes to build stuff and kill it pretty quickly. So just ask Google Music, which, thanks, Google.
How do you feel about that, Adam?
It's whatever. Oh, the Cisco 12-port switch with all ports being SFP. Yeah, those are really cool. If I remember correctly, I think we have one of those here at the office.
Because that's running our additional warehouses.
It does, yeah. It runs the entire complex for us, right? Yeah, so Gary is our head of that, and he handles that part of it. It's actually really cool. I walk in there every now and then just to look at it because it's so freaking cool. Yeah, exactly. I'm just nerd out over it. So my news.
I geek out. You nerd out?
Yeah.
See, I geek out.
You geek out? Yeah.
I geek out.
Well, nerd, I'm just smart. Geeks are.
I'm a hardware guy.
Sure. Yeah, we'll go with that. Don't worry, he gets picked on by all the jocks around here. It's okay.
Wait a minute. There are jocks here?
No.
Just checking.
So here's what's happening in the industry with HDMI 2.1.
Okay.
So apparently, the Xbox Series X is having some issues connecting to the new AVRs from the likes of Yamaha, Onkyo, Denon, Sony, Marantz, all those kind of all the big guys.
Why?
Apparently, we don't know. No one's told us exactly why. And what's interesting about that, on top of all of that, is that it's also happening to the video graphics cards that are now being released by NVIDIA and potentially the ones from AMD, the Radeon series. Those are still being released.
Hardware or software emulation of 4K or 8K?
It's going to be hardware based.
Really?
And so that's what we're running into because it's the same chipset that's in both the Xbox Series X as the NVIDIA. No, I'm sorry. The Xbox Series X is using the new NVIDIA the AMD Radeon graphics, but they are running into issues on both the NVIDIA graphics cards and the Xbox Series X.
When you look at everything out there on the AV side, they're all using the same, we're not going to pick a brand name, but they're all using the exact same processor.
Yes.
Because it's the only processor that's available.
Yeah, they're working on others, of course, but that's the only one that's readily available in the marketplace now.
So every AVR, regardless of the manufacturer, at least as far as the HDMI portion, is having to use the same chipset. So if there's a hardware compatibility between that Radeon or AMD and that one chipset?
Yep. Yeah. Now, from what all the spokespeople from all the different companies are saying is that they're working on it. We don't know if it's on the AVR side or if it's on the source side.
Or just yes.
Or is it just there's just problems? We're still trying to figure it out. We don't know it. No one's really come forward yet to say exactly what it is. If you know more information, definitely put it down in the comment section or in the chat to let us know.
Is the Sony unit shipping yet?
No. I don't think so. I don't think so. You would know better than I would because you've got contacts with Sony.
I haven't made that call because I'm not a gamer.
Well, so definitely keep that in mind as we move forward into 2.1. I'm
careful.
sure that things will get ironed out.
Firmware update 27.
It always happens. We always get some kind of ironed out firmware update that fixes all of it. But right now, if you have clients that are like pushing for it right now and you're about to finish the job and you plug everything in and it's not working,
you ain't alone.
You're not alone. It's okay. Wait for the firmware update. You're going to have some upset clients for a little bit, but yeah, wait for that update on it. So
control the expectations.
Yes. Tell them brand new technology. It should work, but we may run into some problems. So with that, Brent, I think that's pretty much all we have going on today. Do you have any other?
That's a lot.
That is a lot.
That is a lot.
We've put a lot of information out there.
You and I had some interesting tech calls and other things this week, but I think we're getting a little long in the tooth already today.
We are, yeah. So we're going to go ahead and close it up today. Now, Brent, you are gone for the next 2 weeks.
I am. I'll be out on the left coast So while I'm available for phone call and tech support,
Yep.
Adam will be holding down the fort alone, and I believe he has a special guest planned for next week.
It's either next week or the following week. We haven't quite ironed that out yet, but we have a local dealer that does some work with us.
Does a lot of mounts.
Yeah, he does. And so we're going to be doing a discussion on mounts. It's either going to be next week or the following week on that. So definitely check in with that. We're going to have that our special guest to join me for that. And then we have a couple other things going on. What are you doing, Samsung? So definitely check that out.
Maybe it's telling us it's time to go.
It does sound like it, right? And wrap it up, guys. So everybody, thank you for checking into the videos. We really appreciate it. Oh, Richard Zuckerman. Oh, what was I supposed? Yes, 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 yes. Oh, hold on, Richard. Thank you for bringing that up. Brent.
Yes.
Hold
Hi,
for
Richard.
time. Let's see if I can find it real quick. Oh no.
Richard, what are you telling him?
There's a Richard ran into an installation problem, and oh no, I can't find it.
Where is my picture?
Yeah, he's asking where his picture is. He sent over a picture. Richard, I'm gonna have to describe it and maybe recreate it. Do we have? Where's that fiber?
Yeah, I don't have the.
So
fill me in.
Richard ran into a problem. He did a pre-installation with one of our AOC cables. AOC, it's active optical cables, an HDMI AOC. And during the pre-installation, he did the integrator 101 don't trust the drywallers. He trusted the drywallers.
Oh, he called me about this.
Yes, he did. And so what had happened is he had it all laid out for them, perfectly ready to go, nice and wrapped up. Everything was good to go. He said you just have to pull it here and feed it through and make the connection there. No problem, Todd. Thanks for all the questions. It's really great to hear from you. If you have other questions and whatnot, leave it down in the comments or give me a call. So anyways, he did that. Came back to the job site ready to do an installation or ready to
finish.
He did the good thing by going and checking on it before he did the final to start finishing everything up, and he found that the cabling not only got taken out of his dressing for it, but they had somehow taken the fiber, the AOC, and wound up with a massive knot in that fiber. And so it was even a little bit tighter than that. I think it was something like that. And it was so bad. And not only was it bad there, but the category cables were that way. The RG6 that was in there was that way. If I remember correctly, it was bad. It was really, really bad.
Brad?
Brad.
It was really Brad?
It was Brad.
Like Pitt?
I'm pretty sure Brad was the one who did it. So it was Brad. It was bad Brad. I don't know. Really, really nasty. So installer 101.
Trust nobody.
Trust nobody. Which you did the good thing by going and rechecking on it for that. Do whatever you can, all you other installers out there, do whatever you can to ensure that it is already ran for them. They don't have to do anything extra. It's just there. They just have to put the drywall up and not have to worry about it. We'll come up with a solution eventually, right, guys? Yeah. So, everybody, thank you for checking in with us today. Definitely check in next week on Wednesday, where we'll be talking either about mounts, or the week after that we'll be talking about mounts. And if we do something, we'll be talking about something else at that point. And then, as always, Brent, reboot early.
Reboot often.
Don't cut your wires too short.
Call tech support.
And we'll see you next time.
I'm Brent.
I'm Adam.
Goodbye.
See you
I
next
say I was hoping you would go backwards today and just.
Yeah, no, not quite. Let's see. Is this thing going to work for me? And there we go.
Look at that.
Hey, there we go. All right, guys. We'll see you all next time.
Adam. Brent?
Yep.
The token old man?
Token old man. Thanks, everybody.
Have a good day.